valency is 2. So here it will forms Na2CO3, sodium carbonate, and finally NH4. NH4 is ammonium. NH4, ammonium, valency 1, and SO4, here is 2. So interchanging, we got NH4 twice SO4. So ammonium sulfide, ammonium sulfide. These are the rules for writing the chemical formula of an element. So here is all the valencies are mentioned here, or all the charges are mentioned here. So in the next chapter we want to discuss about how to write the valency and how to write the electronic configuration. In the chapter atomic structure, it will be clearly mentioned that how to write the valency of an element, how to write the electronic configuration, and regarding all the things regarding the valency. So in that chapter it will be clear. So after that, after the next video is regarding the atomic structure. So in that video I explain about how to write the valency of an element. So after that you can just go through this table, and then you got a clear idea about how to write the chemical formula of an element. So moving to the last portion of the topic called the mole concept, which is an important topic regarding that chapter. This is the last topic called the mole concept. So before moving to the mole concept, I'll just write an equation such that here I write here 2H2 plus O2 gives 2H2O, which means that hydrogen and oxygen combined to form water. Here, 2 molecules of hydrogen combined with 1 molecule of oxygen to form 2 molecules of water. 2 molecules of hydrogen combined with 1 molecule of oxygen to form 2 molecules of water. Or otherwise we can express it as 4 atomic mass unit of hydrogen. 4 atomic mass unit of hydrogen combined with 32 atomic mass unit of 32 atomic mass. This is 4 unit of, that is 4U means 4 atomic mass unit of hydrogen combined with 32 atomic mass unit of oxygen to form 36 atomic unit of mass unit of water molecule. So here in this equation, the reaction is expressed in terms of molecules, atoms, and in terms of mass. So it is more convenient to express a chemical reaction in molecules or in terms of atoms. That's why a new term formed called mole. That's why a new term formed called moles. So here in this equation, we express the equation in terms of molecules and in terms of atomic mass unit. Atomic mass unit means atomic mass. So it is easy to express, or it is more convenient to express a chemical reaction in terms of molecules. That's why a new term is raised called moles. Here are the concept is just shortened to a picture, that is in a flow chart. So we want to explain that flow chart. Here we consider 1 mole of carbon atoms. So here given that this is not a carbon molecule, this is carbon atom. So if it is expressed in mass, here we take atomic mass. So 1 mole of carbon atom is equivalent to 12 gram of atomic mass. That is 12 gram of carbon atoms. Why there will be atomic mass is taken? Here atomic mass is taken. Why atomic mass is taken? Because here 1 mole of carbon atoms is given. 1 mole of carbon atoms. So atomic mass. Here it is expressed in terms of atomic mass. Atomic mass rather than molecular mass. Why? Because here 1 mole of carbon atom is given. which is equivalent to 12 gram of carbon atom. That means atomic mass of carbon atom is 12 gram, right? So which consists of how many particles? Which consists of 6.022 into 10 raised to 23 carbon atoms. That means this consists of 1 mole of carbon atom consists of this number of particles. These particles are called, or this number is called Avogadro number. And experiment prove that this number is same for all the cases. Avogadro number is same for all the cases. So 1 mole of carbon atom. So given that it is carbon atom, carbon, not carbon molecule, it is given that 1 mole of carbon atom. 1 mole of carbon atom is equivalent to 12 gram of carbon atoms. That is 1 mole of carbon atom is equivalent to 12 gram of carbon atom. That means we have to take the atomic mass, because given that this is atom, and which consists of how many number of particles? 6.022 into 10 raised to 23 carbon atoms. So next one is 1 mole of hydrogen atom. 1 mole of hydrogen atom is equivalent to, given that it is atom, 1 mole of hydrogen atom is equivalent to 1 gram of hydrogen atom. This is the atomic mass. This is the atomic mass. Here the relative mass is considered as the atomic mass. Either atomic mass or molecular mass is taken. Then molecular mass is taken. The molecular mass is took. When the molecular mass is taken, then the moles are given, or the moles are expressed in terms of molecules. It is expressed in terms of molecules. That we have to explain in the next step. So 1 mole of hydrogen atom is equivalent to 1 gram of hydrogen atom. And how many number of particles? 6.022 into 10 raised to 23 hydrogen atoms. So 1 mole of any particle means it may be atoms, it may be molecules, it may be ions. So 1 mole of any particle is equivalent to relative mass of those particles in gram. It may be atomic mass or molecular mass. Clearly, atomic mass or molecular mass. 1 mole of any particle. That means if it is an atom, we will take atomic mass. If it is a molecule, we will take the molecular mass, like that. So it is equivalent to 6.022 into 10 raised to 23 number of that particle. That means if it is an atom, that means if it is carbon atom, that is into 10 raised to 23 into that much carbon atom. 10 raised to 23 into that much hydrogen atom. 10 raised to 23 into that much X particle, that much Y particle, that much Z particle, like that. So finally, 1 mole of molecule, 1 mole of any kind of molecule, any type of molecule, or any molecule, not any type and any kind, it is approximate, it is theoretically not correct. 1 mole of any molecule, 1 mole of any molecule is equal to the molecular mass in expressed in grams. So here we take the molecular mass rather than the atomic mass, because the particle is expressed in terms of molecule. So 1 mole of molecule is equivalent to that much of molar mass in gram. That is equivalent to 6.022 into 10 raised to 23 number of molecules. So this is the concept here. 1 mole of carbon atom here. So generally 1 mole of any particle, 1 mole of any particle, it will be atomic mass or molecular mass or ion, is equivalent to that much particle expressed in terms of atomic mass or molecular mass. And how to find the number of particles? It is simply rightly correct such that it is simply all the case Avogadro number is same. So it is simply that Avogadro number of that particle, 6.022 into 10 raised to 23 number of that particle. So for more accurately, for more approximately, we have to do some problems regarding that. Otherwise, this is not a clear-cut picture, I know. So we want to do some problems to for a healthy reason, such that we want to know more about the mole concept. So we want to know more about mole concept. We want to do 1 or 2 problems regarding that. So next we want to move to that type of problems. So moving to the problem section, here is the first problem. Calculate the relative molecular mass of water. As we know that the formula of water is H2O. Hydrogen and oxygen combined to form water. So what is the atomic